All right, so a couple of things before we get started. I know it's been a while since we've done exponential functions, but going into our next project, we're actually going to need to know how to write and interpret what they mean and the different parts of them. Okay, so I need you to recall a couple of things, okay, before we just jump right on in, okay? Exponential functions are in the form a times b to the x power, okay? So what this means is that we have we have an initial amount here, okay? So this is our y-intercept where we cross the y-axis, all right? We also have b, which is our growth or decay factor. Now remember, if b is greater than 1, we have a growth. And if b is a fraction that's less than 1, it's decreasing, so we have a decay. All right. So looking at this, and the exponent up here, that little x, that usually represents time periods, okay? Looking at this equation, this is where a cannot be 0. Our initial value cannot equal 0, and b has to be greater than 0, but it cannot equal 1, okay? We've spent a little bit of time this week reviewing because of our snowpocalypse, so hopefully this right here is just a huge review. So when we go into writing our exponential functions, what do we actually need to know in order to write them? Okay, so what is needed to write a function for a given situation? Okay, so the very first thing that we need to know straight up is a. And in all of your word problems, it's going to be your starting amount, your starting spot. It's going to be the initial, the original, beginning amount or value, the purchasing price. These are all, what's the word I'm looking for? These are all words that are used in story problems to help you figure out what A equals, okay? So the y-intercept, which is when x equals 0, okay? So that's the first thing that we need to identify whenever we're writing these things. The second thing is b. The factor the function is being multiplied by. It's also known as be a final amount left each time. So we know that if it's doubled, b is going to equal 2. If it's tripled, b is 3, okay? It's the growth or decay factor, or it's the growth or decay rate, okay? And that the rate is what it's increasing or decreasing by, and we use it to find the growth factor by doing 1 plus r for growth and 1 minus r for decay. All right, so I need more space here. So there's a couple of examples, so we'll go back up here. Each year it's 80% of the year before. So 80% would be 0.80 of the year before. So B is equal to, and I'm sorry, let me go back, brain fart. If it's 80% of the year before, that means that 0.80 is the rate. Okay, it's not the factor. Remember, B is the factor. So if it's 80%, that means we're going down. So we have a decay. So 1 minus 0.8. So B is equal to 0.2. Okay, and that's for that example. If we increase at a rate of 40%, increases by 0.40, so it's a growth. So 1 plus 0.40, so B is equal to 1.4. But if it decreases at a rate of 40%, 0.4, B is equal to 1 minus R. Yeah? Yeah. So 1 minus 0.4 equals 0.6. Okay. Yeah. All right, so let's go ahead and look at some practice problems. And I'm going to walk you through quite a few of these, okay? The savings account is opened with an initial balance of $250 and it increases by 4.5% each year due to interest. Write an exponential function that can be used to determine the account balance after X years. Okay, so the key thing that I first see straight off the bat is where it says initial balance of $250. Okay, now the wording says initial, so my starting balance is at $250. Okay, so that's my A value. Easy peasy lemon squeezy, right? It increases, so I see that word increase, so I know it's a growth by 4.5 each year. So I know that my rate that I'm increasing is 4.5%. Now, one of the things that we talked about before Snowpocalypse was that your rate is a decimal. So we have to turn this into a decimal. So when we do, it becomes 0.045, and because it's a growth, we're going to add 1 to it. So B is actually equal to 1.045. Okay, so is this a growth or decay? Because it's greater than 1, B is greater than 1, it's a growth. So my equation is y equals A, which is 250, times B, 1.045 to the x power. Okay. Let's look at number 2. The NCAA basketball tournament begins with 64 teams. I'm just going to stop right there. Begins. It's my starting spot. A is automatically 64. Okay, 64 teams. After each round, half the teams are eliminated. Half the teams are eliminated. So if half of them are going away each time, we have a decay function. Okay, write an equation to express the number of remaining teams. T sub n as an exponential function, and so instead of x, they want us to use n. Okay, so I know that the rate that we're decaying rate is 1/2 or 0.5. So to find the rate, or to find B for decay, we take 1 minus our rate. So 1 minus 1/2 is 0.5. Okay, or 1/2. Okay, so there's my B value. So the equation, Tn equals 64 times B, now you can use the fraction or the decimal, choice is yours, to the n power. A painting is sold for $1,800 and its value increases by 11% each year after it's sold. Write an equation that represents. Then find the value of the painting in 30 years. Okay, so let me see if I can find my calculator. Boom. Okay, a painting is sold for $1,800. So there's my starting spot. So 18, so A is $1,800, and that's the same thing as the y-intercept, 1,800. Increases by 11%. Increases, so we have a growth, 1 plus R, so 1.11. So there's B. Here's A. So my equation, find the value, X years, so Y equals A times B to the X power. Okay, now remember, X is equal to time. This is saying find the value of the painting in 30 years. So T, or X, equals 30. So what we're going to do to find the value of the painting after 30 years, we're going to plug 30 in for X. Okay, so our equation becomes Y equals 1.11 times 30. Now, you can use the table and you can scroll and scroll and scroll until you find X equals 30, but I think it's easier to plug it in exactly the way it's written. So if we plug it in, we have 1,800, parentheses 1.11. Now I'm going to use this caret right here. It's above the division sign, boom. And you'll notice as soon as I hit that, I got an exponent box. And I'm going to type in the number 30. Once I hit enter, that's how much the painting is worth after 30 years. Okay, so we're dealing with money. So give me 1 second, let me write this down. So $41,206. We're dealing with money, so we're rounding to 2 decimal places. So 0.13. Okay, there we go. Pretty cool. All right, so let's look at the back. Do we have any good examples on the back? These are pretty good. Okay, the value of a car is a car question. I like car questions. The value of a car is depreciating at a rate of 5% per year. Okay, whenever we see a percentage, that's going to be our B value. Depreciate means decay. Okay, so we're decaying at a rate of 5%, also known as 0.05. So that's our rate. Okay, that isn't our B value. Okay, each year, the car is worth 95% of what it was the year before. That's a weirdly worded thing. Car is worth 95%. That right there is our B value. Okay, that's our factor. And 95% is the same thing as 0.95. Okay, so I know B, 0.95. And if I didn't know what that B value was, if I know that the rate is 0.05, remember 1 minus rate equals B. Okay, so I could plug in 1 minus 0.05, and I would get 0.95. Okay, the car was purchased for $32,000. So we purchased for $32,000. Write an exponential function of the form to represent how much the car is worth. Okay, so I have my A value. my B value. Yeah, there's my equation. Okay, so do we have a growth or decay? We have a decay because B is less than 1. What is the growth factor? Okay, so factor is our B value. And in this case, it's 0.95. Okay, or 95%. All right, what is the y-intercept? Remember, y-intercept is 0, a. So we have 0, 32,000. What does the y-intercept represent? A. So A is the initial value of the car. Okay, let's look at number 5. A student was asked to find the value of a $2,500 item after 4 years. They were told to use the following function, y equals 2,500 times 0.85 to the x power. So is the value of the item increasing or decreasing? Okay, the first thing I want us to do before we even actually start looking at these, so I know A is the initial value, B is the growth or decay factor. So is this item increasing or decreasing? Is the value increasing or decreasing? It's decreasing, which means it's a decay, because B is less than 1. Okay, so the decay factor, 0.85. All right, so what is the growth rate? Okay, or I'm sorry, the decay rate. Okay, so to find the rate, 1 minus B equals the rate. So 1 minus 0.85 equals 0.15. So there's my rate. Or you can change that to 15%. Okay, what is the y-intercept? 0A, so 0, 2,500. What's the y-intercept represent? Initial value of the item. Find the item after 4 years. So we're going to use the equation they gave us. And plug in the number 4. 2500.85 little caret for 1305.02. Okay. Write an exponential function in the form f of x equals a times b to the x, where f of 0 is 18 and the value of f of x is doubled every time x increases by 1. Okay, so first thing that we need to do is interpret what this means. F of 0 is 18. All right, so this right here is the x value. So when x is 0, so this 18 is A. So what this means, this whole thing right here, means 0, 18. So A is, oh, that was weird. So A is 18. Okay. It tells me that the value of f of x is doubled. That's another fancy word for y, is doubled. So times 2 each time. That's the same thing as b. So my equation, y equals a times b to the x. Okay, write an exponential function in the form f of x equals a times b to the x, where f of 2 is 36, and the value of f of x triples every time x increases by 1. So I see triples every time, so b is equal to 3. So the first thing I'm going to do is look for a b value that equals 3. That one is a 2, so it can't be that one. This one is a 2, can't be C, so I'm left with B or D, okay? Many people would automatically pick B because they see, well, f of 2 is 36. This means that when x is 2, y is 36. In order for A to be 36, this value right here, that x value, would have to be 0. So A actually isn't 36. So it can't be B. The only logical correct answer after that is D. All right, let me know if you have any questions.